appreciate everybody reaching out too. That was cool.
Yeah, good to hear it. I'm glad you're safe, Patrick.
Thank you.
All right, let's get the show on the road. I have one small personal update. We did our honey harvest. This is from the bees. We did that this weekend. It's a smaller harvest than usual because one of the hives died, but it was still quite good. So on to co-op business. Let's see. We have a lot of updates. One of the biggest ones, we were very happy to have heard from the DFI in New York, who indicated very clearly that we're nowhere near the kind of business activity that was intended to be governed by the bit license. So, so we're quite good with it. Oh, nice. Harvest of raspberries. Anyway, so that was good. That means that all the New York State participants need have no worries at all. We didn't think that they would anyway, but it was to get that kind of confirmation. So that's good news. And on other news with respect to the update on the private sale, that's been going well. We continue to close out folks. For those people who are in the Discord channel, they can see the reporting there. I think over 4 million has been closed out so far of the funds that have been committed. Funds are still coming in, and we have several large funds that have contacted us to get into the round. So we're in the midst of setting up all the meetings there. So let's see. In particular, I guess I should be a little bit more circumspect about that. So we can talk about, for people who really are interested to know, we can talk about that offline. Okay, cool. We also have done a lot of housekeeping. So we've moved the bulk of the ether we've received from the private sale over into the out of the addresses that from the private sale address list into a multi-sig that's managed by the co-op. So people will be happy about that. I'm not going off to New Zealand for my honeymoon, having the only private key to the funds. So that's been taken care of. And let's see, we also have, let's see, is Ed on?
Hey there.
Hey Ed, you want to give any further updates?
You gave a good update. So the amount closed, meaning you know, in the wallets and in the bank is about $4.4 million now. So it's a really great and encouraging progress. And you know, additional in the queue, including additional committed. I like to report relatively conservatively, so I'm saying what's closed, but a number of exciting things queued up. I did want to mention also that there were a few individuals or entities that came in sort of a second time. And one of the things that we're doing is honoring the total amount of bonus that is or I'm sorry, we call it discount, but it's computed as a bonus that's due to them. For example, if the first time they came in at $50,000 and the second time they came in at $50,000, we'll give them the 10% discount that's due at the $100,000 level. So a few people have taken advantage of that and came in a second time. So we are certainly open to taking, you know, additional, selling additional rocks to those people out there that are quite excited about the rock. You know, not all of this conversation happens in Discord or Slack because some people want to remain quiet and anonymous. but we have anything else that you're thinking I might add?
No, I think that was good. That was a great update. Let's before we shift gears and start talking about communication channels and other things like that. I really want to just check in and see if people have any questions about what's going on with the private sale or you know, anything about co-op fiscal policy or anything like that.
You mentioned at one point interest from the government about why rocks hadn't been registered as a security. Has there been any news on that? Yeah,
so we have a deadline to respond, and this is from Washington State, not federal level. And we expected this to come, and we've crafted a draft response. It's gone through our review at least once that I know of, with a significant revision to the response. And I will probably get an update today at the the private sale update call at 1, and get a status on that draft. You know, I have a feeling that will go out presently, and then we'll know back. This would probably affect lots and lots of other crypto efforts if they judge our tokens as a security. So I feel, you know, cautiously optimistic. Let's put it that way. Is that to answer your question, Mike?
Yes, thanks.
Sure. Okay, any other questions before we shift gears? Okay, all right, silence is golden. Moving on then, I just wanted to make a few points about, so that people, you know, we've said this many times, but so that people understand. That we're transitioning to a position where Slack is the outward-facing communications, and Discord is the communication channel for the membership. The leadership team will largely be focused on communication with the membership and not as engaged in Slack. So, so people really should, if you want to connect with the team, either the developers or the leadership, please become a member and join the Discord channel. I know that a lot of people have had difficulties joining the channel, but if you sign up as a member and get the email confirming your registration as a member, and it will contain the link to the Discord channel. Once you're in, then we have to do some additional KYC. So you should reach out to me or any of the members who are marked in blue on the list. So that would be me or Ian or Ed or Evan or Kenny. We have to do some additional KYC to verify that in fact it is you who the nickname is associated with the account that registered with the co-op. And once we go through that KYC process, then we will flip a bit. That's right. Navneet is also blue. That's right.
Consider yourself lucky, actually.
We have a blue Navneet. Be careful. It's not a blue world anymore, Max. So then we'll flip a bit, and you will be marked as member. We had an interesting situation happen with I think someone who's been actively interested in the project, going by the nickname Jeff.
Hey, that's me.
Hey, Jeff. Yeah, so I think you got marked as developer by accident, and we'll flip you to member. I didn't flip you last night because I was on my phone and I was having a hard time with the mobile client. If you haven't been flipped to member, I will do that right now.
No worries. The one thing I think it makes sense if the whole point of the developer role is to have a separation between the dev team and obviously everybody else, that they can have a focused chat. I am interested, though, since I am, a full-time developer myself, in whatever, sort of conversations that are going on that can be publicly facing. So like maybe one level removed from the general community, but not the same level as whatever the dev chat is, if that makes sense.
Yeah. Understood. So that's what the member bit does. So member bit allows you to see developers channel. You should be able to see it. At least that's the way I set up the permissions initially. I'll have to go back and check if that's not the case. I just flipped the bit, so you are now marked as a member.
Okay, thanks.
And yeah, okay. So it's the nickname is Jeff, right?
That's me.
Okay, cool. All right. So then, yeah. So and that actually raises an interesting point in a decentralized project. How do we say that this is a developer that speaks for the co-op, right? So your test case actually brought up a lot of questions for me, which I really enjoyed mulling over. We are decentralized. I want people to feel empowered to engage the code at whatever level they feel comfortable. And if they're making substantive changes, and the co-op and the community agrees with those changes, even if they don't have an SOW with the co-op, or they don't have an SOW with Pyrofex, I would want to say, and I think, I'd love to hear from the rest of the community that they are in fact a developer for the co-op. So there needs to be some kind of measure or observable that indicates, the community feels comfortable with that says, this is a developer for Rchain.
So if the defining feature is the difference between someone who has, a statement of work or not, that can itself be a role, right?
Yeah, absolutely. I see that, but maybe there are, mavericks out there who don't want to have that kind of relationship with the co-op, but they do want to engage the code base. And so I would think that something like accepted commits, something on the order of accepted feature level commits, or like if you go and you you do a minor edit on some code, like you modify a comment, I'm not sure that constitutes the kind of engagement that that I would feel comfortable with saying, yes, this is a developer for the co-op.
Right.
On the other hand, if you go in and you say, no, here's a significant optimization on the message flow in Casper, and we see an order of magnitude improvement in Casper, that means that the person has understood the Casper algorithm, seen how the algorithm maps onto the code that's present, and then made a significant improvement. That's the developer, right? In my opinion. And
I think if you can give bonuses to people for contributions, that would be ideal, depending on the legality of giving out such bonuses.
Oh yeah, absolutely. I feel perfectly happy with the bonus program, but that's independent of a mark in the official recognized channels as to whether this person speaks as a developer and has access to all of the ins and outs of the developer conversation. Because I know that.
Okay.
Yeah. So those are different things. And I guess what I'm trying to suggest is that something along the lines of significant commits in the GitHub repo constitutes at least one measurable. We don't have to have an answer for this right now, but I really would love if people were to think about that and come up with some proposals. And again, this is a part of the larger governance discussion.
Yeah, and I think bonuses for specifically the kind of development you're talking about would constitute a measurable.
Okay, yeah, that's true. So what you're saying is, if the co-op recognizes recognizes in a fiscal way, or in some kind of monetary way, or tokenized way, the contributions of the developer, then they are developer for the co-op. That's an interesting proposal. So let's apply. I'm just going to borrow something from the outside, right? So Grigory Perelman, right? He solves Poincaré, and he refuses, all the bonuses. He refuses the Fields Medal. He refuses, all the other prizes that were offered to him, right? Does that mean he's not a mathematician? So the same thing could happen here, right? A developer refuses all the bonuses because they don't want to feel beholden in any way, fiscally or financially. They're in it just for the code. I mean, this is an outlier case, is an edge case, but I'm just, I just want to check it out and make sure that we have these edge cases covered. In that case, the fiscal relationship is not a good proxy for recognition as a developer for Rchain.
Yeah, Greg, I'd say that's appropriate, but there's also ways to build reputation that's not necessarily financial that can still be tokenized. So come up with a scheme where contributions are, for lack of a better word, tokenized, and then that is used as a reputation and or financial benefit, regardless of acceptance or not.
Okay, that's a good thought. Awesome. Well, I just wanted to throw that out there, and thanks, Jeff, for being the guinea pig on this, and
Sure thing.
and sort of causing. At least I found it very edifying to kind of go through some of these issues and think it through. Okay, so moving from there.
Is there any reason to exclude a member from reading or even communicating on any of these developer channels? We're having rolling discussions or type theory. I can't think of any except perhaps if they're being disruptive, and that's an entirely different question.
Right. Yeah. Again, I'm all for radical transparency. So I'm totally happy if we want to make all of those open. I know that some developers over the last 2 years have come to me and said, I feel less free to speak my mind if I know the channel is open. And so I want to be sensitive to that while also being committed to radical transparency.
The other possibility is just message spam, right? The sheer number of messages. We need to know which channels we have to pay attention to as developers.
Yeah, that's a very practical condition. Yeah.
Yeah, I think as a dedicated team, the ability to stay focused and have high bandwidth conversations where you know the whole context and the depth of the conversation is really important. And not every developer wants to take on the role of educator of the community. So I think having a developer channel for those that are invited in is important.
Yeah. Okay. So I think I'm okay with that. I had to wrestle with that myself for a lot. But
I mean,
but
the other
thing
too is, the other thing too is I've got more comfortable over time, but just the ability to ask a question that you might be personally embarrassed by, right? It's like I asked about a week ago, I really don't understand namespaces, right? Some developers might be embarrassed, or anyone might be embarrassed to ask a question along those lines. Or, another question is, putting the spotlight on somebody else. Greg, I really don't understand how you describe namespaces. Please describe it, right?
Yeah.
It's kind of a decorum thing, but I think most importantly is just the ability to keep the dev team as focused on the most essential.
That's a really good observation, and it's something that I think all of us have to face again and again. The flip side of it, and this has been a part of my purpose, is that if I keep maintaining this position that there are no stupid questions, there are no embarrassing questions, and oftentimes what appears to be a basic question or a question I've heard before is either neither basic, but instead foundational, or I hear it in a different way, and it opens up a new door. So again, the other principle is sort of radical inclusion, like including everybody. And because sometimes the naive question or the it can also be the question that no one thought to ask. And so I want to leave the door open for all of that kind of impulse and activity. And so I don't necessarily see these as that we have to answer them like with a steadfast policy, but rather we have to use judgment. We have to use discrimination and discernment about, is this a time where I really need high bandwidth conversation and not to be distracted? Or is this a time where taking the time to explain something that I thought was basic might be edifying? Yeah. Both to me as well as to the community member that's asking. So those are, again, I just think this is really valuable stuff, and keeping it alive is what I'm hoping to do. Okay. Any other questions along those lines?
Hey, since we're at a relatively quiet point, I wanted to invite W. English, or maybe you're looking at your phone right now. So, hey, how are you? So I just wanted to give you an opportunity. You're on mute, just to introduce yourself if you're inclined to do so.
There we go. I think I'm unmuted now.
Yeah. Hi. If you'd like to introduce yourself, feel free. I'm sorry to put you on the spot.
No. Thank you, Ed. We had a conversation just 2 days ago, which I found very helpful and enlightening. And as I mentioned there, my background's in political science, political economy. I teach at Georgetown and have been involved with some startups in the academic space, but very interested in blockchain technologies for everything from governance issues. And some of the stuff Rchain wants to do in scaling, I think, is also very interesting and attractive. So I've been reading up a lot in the project just the last few weeks. I've been looking at blockchains for many months now, but delighted to be part of the conversation and be able to learn from some of the stuff you're doing and hearing, even thinking through some of these issues right now is very edifying as well.
Cool. No, it's great to have you as a part of the community, and really looking forward to hearing more, especially your insight or just falling on the issues of governance. It's a fascinating area.
Oh yes.
Yeah. Very, very happy. You're always welcome.
Yep, absolutely. So unless there's any more discussion along the communication channel lines, I'd like to move over to some technical updates. Griff and I have been talking about scheduling a demo. Griff, if I understand you correctly, you would feel more comfortable scheduling the demo for next week or the week after. Is that correct?
Yes.
Oh, awesome. Very, very good. But you had some encouraging results. Do you feel comfortable just talking about those results and then as a tee up for the demo in the upcoming weeks? Ooh, silence.
You're muted, Griff.
Oh, great. Yeah, definitely have some things to say. For those of you who saw my previous demo, it had to do with implementing a kind of Prolog unification means of processing queries. And so that was interesting, but that's separate from what I'm doing now, because we actually need a database once we get the queries processed. And so instead of rolling our own, we want to go find something that's out there already. And we've got a few candidates. So basically take the work I've done and plug it into an industrial strength database. And Nash, who's had a lot of experience in systems engineering, say at Google, has suggested Lightning and Lightning database. And it has a number of interesting properties. It's written in C, and you actually include it into your code as a library, as opposed to running it separately as a service. And this gives it all sorts of fast performance. So what I've done is I've plugged Lightning into our storage layer. And so I've been putting it through performance tests. And in particular, what I'm doing is I wrote a test in C using Lightning, and then I wrote the equivalence test in Scala in our key value store going through Lightning, and then compared the two. The C version is kind of like the speed of light. It's as fast as we ever expect anything to go. The Scala version will be a little bit slower, but we want to know the degree to which it's slower. And we're using Scala because it's kind of a more modern language, and it's reduces a lot of errors that might occur if we use C. The good performance news is that we're getting the kind of results that we'd expect. The Scala version is not going to be as fast as C, but it's performing within expected limits. So we want to set down some benchmarks for how fast C goes by itself. Again, that's kind of the speed of light measurement. It's as fast as things are expected to go. And then we'll compare our Scala version to that. And then if we decide to try other databases, for example, Mongo or something else, as a comparison, then we will already have those benchmarks. So that's how things look right now. I'm happy to take any questions.
So one thing that came out when we were doing some of this due diligence, Griff, is that Lightning is transactional, which
Correct.
is nice. And so we've talked a little bit about how to look at those local transactional boundaries with respect to some of the testing. Did you have any more to say on like how your initial tests with respect to begin and end transaction? And
actually, I'm still. We've got tests where we use one transaction for the whole test. The other endpoint is to use for every operation we do, either a store or retrieve, to just use a single transaction. And yeah, I've got some sort of programming issue right there that I'm still struggling
cool. with. No worries. I mean, all this is just, it's the joy of programming. And then the other thing is that can you talk a little bit about kind of the size of the load and the relationship of the payload to the testing?
Actually, I don't have my data in front of me right now. I'm sorry.
No worries. No, it's not a big deal. So I mean, essentially, I was just I wanted to lay out the methodology for the community. So essentially, what we want to do is look at payloads that represent writing effectively blocks. Our notion of block is a little different than other blockchains' notions of blocks, but for the purposes of this discussion, we could think of the payload as a block. And then what we want to do is to look at kind of various transaction protocol profiles, right? So we want to look at something like a few hundred operations per begin end transaction, with the final transaction either being with the final transaction, let's say, being the update of a block to the local store. So that's roughly the kind of profile that we're looking at, and we want to get a good feel for what that looks like, both with the C and the Scala implementations. So far, what we're seeing is incredibly encouraging, but we want to get a little bit more granularity and a little bit more just fine tuning on what we can expect on the back end. And this is actually a really good time to do this, because then the code is not going to be so wedded or entangled or embroiled with the other components, like the comms layer, for example. Here we have just clear, straight up back-end storage. And so if we do see some significant slowdown over these numbers, then we know we're not pointing to the back end. We can point somewhere else, the consensus process or something else is likely to be the culprit when we do this. So let's stop there and see if there are any other questions regarding the work on storage. Okay, sweet. We can move on. Is Kent around? I guess he's not here today. So Kent's been really doing some significant work on the compiler and digging into the virtual machine, and so that's he's developing a bunch of sample contracts and driving out the performance of the compiler and the performance of the VM with respect to those sample contracts. So this is very, very good news. I'm very excited about the work that he's doing. I wish he were here to talk about it, but it's maybe next week we can get an update on that. Mike, do you and or Tim have some updates for the community with respect to the virtual machine?
Development continues pace. We've just hired another guy. We've got a bunch of continuous integration tasks to do. We're hoping to very soon have a shell, kind of a stub VM that can be downloaded and run. It may only support 4 opcodes at the time we release it, but it will be packaged and deployable, and you can feed it a binary file to execute. And so long as it understands those 4 opcodes, only those opcodes, it'll run. But I think there are something like 8 opcodes that don't make any method calls to other classes, and then another 8 or so that only make a single method call. So once we do that one method call there, we'll have a fair set of opcodes to play with. And then there will be, we also need to set up the testing framework, hook it up to GitHub so that when commits run, it updates and rebuilds. We want to write scripts so that rather than doing a pull request through GitHub, you run this script which runs the tests first, and if they fail, it doesn't make the pull request. Once the pull request is approved, you run another script that will rerun the tests before submitting to make sure you don't break anything. If there are conflicting submissions, right now we can run all of the tests on the entire system because it's small, but eventually we'll get to the point where everybody's running their own tests. If after submitting an update to yours that doesn't break your tests, that breaks someone else's, then we'll pick out those particular changes and alert the devs and so on. All of that sort of stuff is tasks that we now are working on getting in place and assigning out to people.
That's great. That's awesome. Doing software at scale. Wow.
Greg, I have a question about EVMs and opcodes and namespaces.
Mm-hmm.
Do you anticipate that there might ever be a significant need in a particular namespace for customized opcodes?
Yeah, I mean, it's certainly the architecture would support that. It becomes a lot more. So if you're talking about super opcodes, so opcodes that kind of aggregate a bunch of opcodes all into one operation that's considered atomic with respect to the execution, that's very reasonable, right?
Okay.
If we start talking about opcodes that are different opcode sets, now you have proof obligations. And so again, it's doable, it's possible, it's just a lot more work.
Kenny, there is a related topic to this, which is on a particular namespace. Say you wanted to use a specialized processor or a graphics card in order to compress video, for example. Then there may be a need to trust certain foreign functions on a namespace, and then that trust relationship and declaration be made not just for those foreign functions, but perhaps even for the specific versions of those libraries that you're going to call. And so that needs to be figured out because not everything is going to happen on the Row VM.
That's correct. Yeah. So Ed makes an important distinction. There's a distinction between adding in a library, which is packaged as a foreign function, versus actually changing the opcodes.
Okay, that makes sense. So there's still enough flexibility that, you know, depending on the namespace, what it's trying to do, that they can get that done without, you know, going through the process of changing the virtual machine.
That's correct. That's exactly right. The other side of this is that you then have to trust it. Right? If you package as a foreign function, then you have to trust it. That's why we think namespaces are a good idea, right? Because the namespaces namespace can come with a kind of trust manifest. This is the extra stuff that we're going to be using here. I hope you trust it. And then go ahead.
Would there be any so I'll confess my somewhat ignorance of what ZK snarks can do, but my general understanding is that they can do something like proving the inputs to a particular program. Would something like that help in the sense of foreign functions if there's some level of proof that you could get out that at least you can have something that you can verify?
Yeah. It's helpful. I'm just right now. I'm call me conservative, but I'm very skeptical that ZK snarks are going to be usable in the next little while, let's say.
Fair enough.
Yeah. There's another thing that this touches on, which is cost, right? So with respect to the cost model, we will have an issue that we need to put a price on the use of a foreign function package, because there's compute associated with it, right? And but I like the fact that becomes market driven. There, you know, if there's a namespace that offers a particular set of foreign function capabilities packaged via foreign functions, but they price themselves out of the market, right? That's that. And then along those lines, one of the things that the team has been working on, and would love to get the community's thoughts on this. We've been going over compiler revisioning and multiple compilers. And what we've been looking at is when a contract is deployed, where is the bytecode generated? And what are the security characteristics and security stakeholders? What's the threat model? What's the attack model? And who are the stakeholders? And then how that relates to the economic incentives with respect to the platform. So we've had a couple of meetings on this. We've drawn kind of a basic interaction diagram, identifying all the different stakeholders and some of the flows that are associated with the compilation of contracts that are being deployed. The aim is to get the working draft of the document out to the community in and or around the time of the general membership meeting. So that's that's something that we really want community engagement on, because it will impact the community in terms of you know, where the trust is placed with respect to compilation, and how that's related to, I mean, what we're trying to do is to get to an architecture where we minimize even soft forks, right? If the architecture is already set up so that you can revise the compiler, and the tool chain is already a part of the blockchain, then there are very, very many fewer soft forks that you have to deal with. And so that's why this is an important set of issues for the community.
Now, wouldn't consensus on what the code does be a Casper issue?
Yes, it is. And that's exactly what we're trying to do. So when you look at the basic flow, you know, a developer comes in to register a contract with the blockchain. The developer has to say, well, you know, this code has been compiled, or I expect that one of these compilers to be used in compiling that, and no others. right? And then if it is the case that the validators or the nodes are running the compiler, right? Then they have to agree. There has to come to a consensus about which compiler is being used for the deployment of this bytecode, and then the deployment of the code is also a consensus-based transaction, right? So that eventually what you get is the key or the name of the contract, and its formals and types points to some source code on the blockchain and points to some bytecode, and that you have a clear relationship between the bytecode and the source code, knowing that there's this compilation relationship and a correctness relationship between the two. So yeah, all right. So there's that, and that brings us to back around to some social issues. So membership meeting, if memory serves, is the 24th of October. Mark your calendars. Kenny, do we have any updates on venues or anything like that?
Yeah, so I reached out to the hall at Fauntleroy. I haven't heard back yet. I do have a reservation for the Washington Hall, so that's currently that's the primary venue for the membership meeting.
Mhm.
But if we can get Fauntleroy, I will. I probably won't wait much longer, just because I'm nervous about getting this close and not having a venue.
Yeah, of course.
Yeah, I mean, I'd love to have it at Fauntleroy if I could, but fortunately they just haven't got back to me. I was going to reach out to them again today. Maybe I actually try to call them.
Yeah.
But if not, then the hall at Fauntleroy, or the Washington Hall, is on. It's not quite. It's like South Capitol Hill, very north Rainier kind of area. It's a nice hall. It can seat up to, I think, 300 or 100, and maybe it was 150. That should be plenty for our needs. And we'll have audio visual there. We'll have tables set up. We'll have a few other things. Evan and I are working on the agenda now, but yeah, we should have everything set up and ready to go. And the agenda will be published prior to the meeting, and everything will be the community will be able to see everything that's going on well in advance, so that they can make preparations if they so choose.
Excellent, excellent. One of the agenda items that is important because it resulted in a board resolution is the lockup of the rocks between now and the Mercury launch. So the board passed a resolution, if I recall correctly. We passed it, right?
Yeah.
Yeah. Okay. So the board passed a resolution that the rocks are all but 200 million of the rocks are locked up, and that 200 million is basically we're trying to make sure that we're conservative. So there's 75 million that are committed for the private sale, and then there are some rocks that are committed for compensation and other kinds of contractual commitments that the co-op has, and then we're leaving ourselves a little bit of padding in case anything comes along, and that's locked up until the membership meeting. And then at the membership meeting, we will come to some kind of agreement on the fiscal policy with respect to lockup of those resources. And so I'm hoping that we will have good, informed, and vigorous debate about that. But as Kenny said, the agenda for the membership meeting will be published long in advance. I just want to make sure that everyone has at least this issue, which I know a lot of people have been concerned about. At least issue they've kind of done their homework. They've thought through positions and are ready to engage. All right, let's see. Anything else that we need to talk about here? I know Mike and I have been having a good fun on the ladle algorithm. We keep dancing around this issue of whether or not it is of enough utility to have a good graph language. So I personally, I've been looking at. Many years ago, I came up with a language for graphs that sort of gives an algebraic presentation to graphs. It's in the same vein as the kind of language that Cardelli, Gelly, and Gardner came up with. So there's a good tradition for this kind of language. But what we're looking at now is whether or not those kinds of graphs are can we constrain them? Because the only kinds of graphs we're interested in when we're considering the ladle algorithm are graphs that are generated by the rewrite rules. And the observation that I made with Mike, I guess it was Monday, was if you think about the how do I say this? Just a little bit of context. The graph languages that are like if for those of you who are familiar with the dot graph specification or some of the Java graph packages, a lot of graph languages insist that you present a graph as nodes and or vertices and edges. But the problem with that is that it ends up blowing up in terms of complexity. As the complexity of the graph grows, the presentation in terms of just nodes and edges, or adjacency matrices like that, that grows at a much faster rate than the complexity of the graphs, because most of the graphs that we're concerned about have some algorithmic character, right? So most of the graphs we're interested in are generated by some kind of set of rules. And in particular, in the case of the ladle algorithm, when we're talking about rewrite systems, they absolutely have a presentation in terms of a set of rules. So there's an algorithmic and algebraic nature to the graphs that are being considered. And so it would be better if we had an algorithmic presentation of the graphs themselves. And then the point was that the rewrite systems, if you look at them the way they're presented, the graph is implicit, and again it has this kind of nodes and edges feel to it, rather than having a more graph-like presentation. The graph is generated from the rules, but you don't in fact, I was just reviewing a presentation Vlad had given on an argument for liveness. And he was struggling with exactly this kind of bookkeeping, how to specify the graph of the message flow in the Casper algorithm. And this is because the graph-like nature is not is generated from the rules rather than explicit in the rules.
Hey, Greg.
Yeah.
You're saying...
Yeah, I think that, you might want to generate them in the graphical lambda calculus to kind of simplify the...
Yeah, that notion of graph is a little different. It's a little different. But so there was another question coming in?
This is my own, ineptitude at trying to understand what you're saying. The connection between graph and the rewrite rules, is that to say, like, as we jump through rewrite rules, that you are creating some sort of a graph?
That's correct. That's right. So you begin in a particular state or with a particular term, and then from that state or from that term, you have a bunch of rewrite rules, right? And employing one of those rewrite rules creates an edge from that term to the next term, or from that state to the next state, right? And so if you just keep running those rewrite rules over all the states or terms that you can reach, then you generate this giant graph.
Got it.
Right. That's the thing to think about. And I mean, I'll just let's see. People can take a look at this. It's actually worthwhile. It's over on the Lighthouse GitHub. I've actually produced just so that people can understand. I'll do a quick screen share because it's kind of fun, and I like to have some technical fun in these conversations.
So are you saying, like, let's say that we have constructed some complete graph of a set of rewrite rules, and then we perform some operation on that graph. Now we have a new set of rewrite rules?
No, I'm not talking about evolving rewrite rules. That you can absolutely do that. Not saying that can't be done. That's a lot of fun to look at those kinds of ideas, but that's not what we're talking about here. So here, let me let me try to give I'll do a screen share real quick. And as a lead up to this, I will, I just want to say that most programmers are very familiar with recursive or algorithmic presentations of other kinds of data types. So if we think of a graph as just some data type, right, then if we wanted to follow the pattern in which we build up lists, well, the pattern in which we build up lists is we start with the empty list, and then we have some operations which allow us to take a list and adjoin elements or combine lists, things like that. So that's kind of an algebraic presentation of the data type list. And that data type we know to be well, it has good properties. For example, it's a monad. And that's very familiar to most programmers. So the idea that graphs don't have that style or flavor of presentation seems very odd, right? It's like a hole in our thinking. So here's a way to do the same kind of thing, right? So we start here. We say a graph, just like a list, is either the ground, the empty graph, or if you had a graph, you could adjoin a vertex to it, right? And so here's kind of the graphical view, and here's an algebraic view. So over here is the algebraic view. So we're saying G is of the form, I'm basically giving it an algebraic data type description of graphs. G is of the form, either it's 0, or it's adjoining a vertex, or it's picking out a vertex in the graph. Right? And the reason that is important is because when you form an edge, you always form an edge between two named vertices, or between a set of named vertices. So these two operations go together. You pick one, starting with a graph, you can build a new graph in which you have named one of the vertices. This part here is not named. This part here is not named, but this part here does the naming. And then once you have named them, then you can build an edge between two named vertices. And then the other thing that you can do is you can combine two graphs. So this is basically building up, I have a component over here and I have a component over there, and then I just put them side by side. And this picking out operation generalizes to naming subgraphs, which is not the same as algorithmically determining if one graph is a subgraph of the other. It's a separate operation, which is to name. You have a subgraph in mind. You have it in hand, and then you just name it. Oh, can you hear me now?
I can.
Okay, good. All right. So what the thought is that in the case of ladle, these cool. So in the case of ladle, these vertices that we adjoin are not random. They're not just any old vertex. They derive from the term structure or the state structure. So when you adjoin a vertex to a graph, you're only allowed to adjoin vertices that are governed by the algebra of the terms. And so that's the kind of refinement of an algebra like this that allows us, that might give us a kind of a nicer graph language. And likewise here, we don't get just any old arbitrary edge. The edges are in one-to-one correspondence with the rewrite rules of the system, whether it's the programming language operational semantics or the virtual machines transition function. These edges come from there. So to be more specific, in the case of the row calculus, the only kind of vertices that we could adjoin to a particular graph would be terms in the row calculus. And the only kind of edges that we could create would be edges that are related to the com rule. So the com rule would dictate the edges inside the graph. So that hopefully puts a very fine point on your question, Jeff. So anyway, that's
I think so. I'm just curious. I was just curious if we were attempting to construct the entire graph of all terms in Rolang, or given like a series of terms, some particular graph, and then like we're transforming between different graphs, or like then we're modifying those graphs.
Yeah, so that's a good question. So when we're looking at the ladle algorithm, we have the luxury to think about the entire graph, right? So when we're thinking about the model of these things, we think about the entire graph. But when we're thinking about the inhabitants of a particular type that is generated by the ladle algorithm, we are thinking about subgraphs of that entire graph. And what we're really talking about is how the types are related to subgraphs. And so therefore, having a graph language essentially helps with those kinds of calculations. And that's really what this is about, is providing additional tools to the theory that make it easier to write down the distributive laws. That's really what it comes down to, is having some additional technology that people can use to do these kinds of calculations and make the presentation of the inputs to the algorithm a little more compact, a little simpler. The important point, like if I go back so that you can kind of get a sense of this, to get a sense. If you look at the discrete graph, and I'll just go through this very quickly, and then we can, because we're over here. The discrete graph is given essentially a two-line specification. So this is the discrete graph within vertices. Right? The discrete graph with 0 vertices is just the empty graph. The discrete graph within vertices is, well, just take a fresh vertex and add it to the empty graph, and then lay that side by side with the discrete graph on n-1 vertices. Right? So those are all graph operations, and I've now given a two-line algorithmic specification of that graph. I didn't. You can utilize this two-line specification to reason about of all graphs that have n vertices for each fixed n. Right. So that turns out to be an infinitary object, and yet I have a finitary description. If I now I can walk up I can walk up the complexity a little bit. So moving from discrete graphs to chains, as you might expect. So now they're actually, I've introduced edges, right? So as you might expect, the specification turns out to be, again, just 2 lines. So there's a little property that's required, which is to note that for all n, chain of n is going to be of the form let x equal y in G. So it's always a let. And since it's always a let, we can always build an edge between the results of chain. And so chain of 1 is just let x. So you name the single vertex in discrete of 1. And then chain of n is, since you know that this one is a let, and you have and you can easily build a let for discrete of 1, then you can connect those two with an edge, and that's how you get a chain of edges. And so again, notice that the complexity of the graph description is remaining constant. It's a 2-line function, even though the complexity of the graph has jumped up considerably. And now if I go up again, so I add cycles, I'll just, you can stare at this at your leisure. This is in House Talks. If I add cycles, it's a one-liner modification if you have chain, right? You just connect the end of the chain to the beginning of the chain. So notice that the complexity of the graph has again grown, but the complexity of the algorithmic description has not grown, or not by very much. And then finally, complete graphs. So this is, over all nodes connected to all nodes. The only point to consider is, and then you can stare at this at your leisure, is that the complexity of the algorithmic description of this graph has again remained a one-liner program, whereas the graph itself has grown an enormous complexity, right? So it's a much, much, much more complicated graph when you're talking about the complete graph on n vertices. But the algorithmic description afforded by this graph language is much, much smaller. And if you compare trying to specify a complete graph for let's say 10 nodes in dot versus this specification, you will see this wins hands down, like, by many orders of magnitude in terms of the complexity of the description. And this is what we're saying, is that most of these descriptions, when we're talking about the ladle algorithm, have this kind of algorithmic shape. And that's why this kind of approach looks promising. All right. Thank you for letting me bend your ear on this. We've gone way over. Any other questions or comments before I give the time back to the community?
I had a quick question about something you said really in passing about the compiler strategy. You said somebody was working on a document and you were hoping to get the document out.
Yes, right. Yes, that's right. So, okay. So Nash was asking some really great questions about who are the stakeholders, what are the threat models, and what are the economic incentives.
Right.
We've been driving that through, and I've been using the interaction diagrams as the methodology to elucidate the questions, make the clear statements about our positions. And I'm basically just codifying that all up in a document. And eventually I hope to get some help on that document. But this is the kind of document we want to hand over to the community for review, for to get thoughts and feedback and that kind of thing.
Okay, thanks.
Sure. Awesome, guys. Thank you so much. Thanks for letting me bend your ear about algorithmic graph theory, one of my pet hobby horses. And just a reminder, I will not be here next week or the week after because I'm getting married this Saturday, and then my bride-to-be and I are off to New Zealand for a couple of weeks, and I have promised her full attention, no attention on Rchain or other things.
Greg, I'll be helping to moderate the meeting over the next couple of weeks so you can enjoy your vacation.
Thank you so much. I really appreciate this. This community is so full of dynamic and interesting people. I feel very confident that you will have satisfying conversations, and there's lots to talk about. So, awesome. Thank you so much, Meta. All right. You guys have a good 2 weeks, and
see you in a couple hours at the stand-up.
Yeah. Yeah.
Thanks.